Hey, we're continuing our learning target of transformations of functions. Right now, we're looking at a logarithmic function. And what a log does, what we'll talk about later on, logs cancel out exponents. So it's an inverse of exponents, which I talked about in the other video that you should watch today. What do the particular features in the log function end up doing? So once again, on its own, seeing everything, I think, is a little bit challenging, just looking at those two functions. So now looking at the individual parts, what does the negative out in front do? So there's our log of x, and what you should notice, it's an exponential but turned sideways. If I pull up 3 to the x super fast here, those two kind of mirror each other, right? They diagonally mirror each other. So sliding down here, what does that negative in the end end up doing? Well, it flips it vertically. What was going, starting low and then coming flat, started high and then is flattening out, but as a negative instead of flattening out as a positive. So once again, a negative out front, the A, if it is a negative, it does a vertical reflection over the x-axis. Okay, there's the x. How does the 3 on transform it? So once again, look at just what the 3 does. What you should definitely see is at a value such as x equals 1, real quick. Not 13. Okay, my bad. Let's try an x at 3. Okay, at 3, the value was 1. Now at 3, the value is 3. Well, how do I make a 1 into a 3 and then also do this for other points like 10 gives us a 2, and then a 10 gives us a 6. Well, times by 3. So that is a vertical stretch with a factor of 3. What does on its own the negative 2 end up doing? Well, the best point is the x-intercept. The x-intercept moves from 1 to 3. That is still a shift right 2 units because it's x minus h. The h is a positive 2, so 2 units right. And what does the plus 1 end up doing? Well, the plus 1, you saw the orange graph move up, and taking the minus 2 away, very clearly what was a 3 giving us a 1 is now a 3 giving us 2. So that is a shift up 1 unit. Okay, so AHA does the reflection and the stretches. H is moving left and right. It's in by the x, so it can't be trusted. It's opposite because it's minus h. So minus a positive shows up as a minus. If you ever get minus a negative, it shows up as a plus. And then the k, it is what it is, moves it up or down. In this case, it's positive, so it moves it up. And then lastly, evaluate the function for a few values. So to make sure you got things right on a Khan Academy problem, let's see what is happening on the function that has everything at a couple values. And quite clearly, we'll turn the parent function off there. At 3, we get a 1. At x equals 5, we type that in, we get a negative 2. And at x equals 11, we get a negative 5. So that is because it got flipped. It's trending downwards instead of upwards. And we've got the points. 3 gives us a 1. X of 5 input, it gives us a negative 2. And x of 11 gives us negative 5. And those are our values. Always make sure you're hitting, especially with the curve, I recommend you find 3 values you hit perfectly and make sure you match everything up. And that's why we're choosing those values, because as we go along, it looks like they're perfect intersections, and Desmos confirms that they indeed are. So use this video to complete the Khan Academies, and in particular, the one on transformations of logarithmic functions.